Okay, so when we were talking about logarithms again, we talked about the fact that with logarithms, we would, since with exponential functions, I had to have this value that b had to be greater than 1 and or it had to be greater than 0 and x had to be any real number. So when we look at this, when we do the inverse, then we realize that for the domain of the inverse, or for the logarithmic functions, the values of x have to be greater than 0. So when we look at any logarithmic function and we graph it, we see that it's always going to be greater than 0. When we look back at the graphs that we did earlier, we'll notice that all the logarithmic functions, our x values are greater than 0. So again, for our logarithmic functions, our x values are greater than 0. So logarithmics, remember, have that asymptote at x equals 0. So they can't go negative. So we have to make sure that our domains are positive. So that means that 5 minus x has to be greater than 0. It has to be a positive number, and it cannot equal 0, because remember, our asymptote is at 0. So I'm going to solve this, and I end up with all the x values that are less than 5 will work for this problem. So if I put in 5, I'm going to get 0. I can't have that. But if I put in 4, I'm going to get 1. If I'm going to put in 2, I'm going to get 3. So those are all the x values that I'm allowed to put in there. And I can also put negative values in there. So for this one, I'm looking at this and I'm saying 1 over x squared has to be greater than 0. So when you think about that, all I have to say here is x can't equal 0, right? But if x is any other number, if x is negative 2, negative 2 squared is positive 4. If I put in positive 2, I'm going to get 2 squared is 4, so that's 1/4. So no matter what, they're all greater than 0, except for this one term where x can't equal 0. And then we have problems like this. So this is where we have to do our breakpoints again. So remember when we did breakpoints a while back, we have to look at the numerator and the denominator. So we look at the 2x and we look at the x minus 3, and we want this whole fraction to be greater than 0. So to remember, to do our breakpoints, we take the numerator and set it equal to 0. So x equals 0. And we take our denominator and we set it equal to 0. So x has to equal 3. So 0 and 3 are my breakpoints. Something is happening to my function at those 2 points. And what I have to decide is what's going to happen in the negative, what's going to happen over here less than 0, what's going to happen between, and what's going to happen in the positives. So remember, you can use your calculator or you can pick numbers. So if I put negative 1 into this problem, 2 times negative 1 over negative 1 minus 3 is negative 2 over negative 4. Negative divided by negative is positive. So all values here are going to be positive. If I put 1 in, so 2 times 1 over 1 minus 3 equals 2 over negative 2, which is negative. So all the values in here are negative. And then I pick 4, for example. And I'm going to get 8 over 1, which is positive, so all the values over here are positive. So since I want values greater than 0, I want the values to the left of 0, and I want the values to the right of 3. So negative infinity to 0, and 3 to infinity, and the union of those two. So that would be my domain of that logarithmic function. Okay, here's another one. So we have log base 5 x over 8 minus x. So again, I want this to be greater than 0. So my breakpoints are going to be x equals 0 and 8 minus x equals 0. So negative x is negative 8. So positive x is equal to 8. So 8 and 0 are my breakpoints. And then I test those values around the breakpoints, and I get negatives below 0, I get positives between 8 and 0, and I get negatives above 8. So that means that I want the values between 0 and 8. So my interval notation to show what my domain is, my domain are all values between 0 and 8. Okay, so we can also do this if we had exponentials in here, if we had quadratics in here. I could do my domain and range by factoring and things like that. So the last thing we're going to talk about here is common logs. So a common log is any log that's written as base 10. So those are the values that we can use on our calculator for our common logs. Again, the button on our calculator that just says log over here, that is a base 10 log. And then natural logs have a base of e, so natural logs are the ln. So anytime we have something that is a base of e, then we'll do that. Let's go back and do one more domain problem. So what if I had this one? I had log base 7, and I had x squared plus 7x plus 10. So again, in order to figure out what my domain of that's going to be, I have to set this part equal to 0. So when I do that, in order to figure it out, I'm going to have to factor this. So this is going to factor into x plus 5 and x plus 2. Okay. So that means my breakpoints are going to be -5 and -2. And now I want to test the values around that. So at -4, if I put -4 in here, I'm going to get -4 plus 5, which is 1. And I'm going to get -4 plus 2, which is -2. And negative times positive is negative. If I put -3 into this problem, I get -3 plus 5. That's going to be 2. And I get -3 plus 2. Let's see, what did I do wrong here? -4 plus 2. Oh, you know what? -4 is not less than that. -6. How about -6? Okay, so we put -6 in, and we get -1. And we put -6 in here, we get negative, so that's positive. Then we put -3 in again, and we get positive here, and we get negative here, so this is negative. And then we put maybe 0 in, so we get 0 plus 5 is positive, and 0 plus 2 is positive, so that would be positive. We want the positive values. So we want these values from here to here. So our domain for this problem would be -infinity to -5, union together with -2 to infinity. Okay. All right, so let's look at this last problem. It's a word problem. All right, so this word problem is talking about typing speed. So the following function represents the average typing speed in words per minute for a student who has been typing for T months. So they said T has to be something between 0 and 16. So I'm assuming that if you practice your typing for 16 months, you should probably peak out and be an efficient typer. So it says, what's the student's average typing speed to the nearest word per minute when they first start typing? So that means that the number of months is 0. So we put T equals 0 into the problem. So what you're going to do on your calculator is you're going to say the 5 plus 29. We're going to hit the LN button, and we're going to do 0 plus 1. Okay, and we get 5 words per minute. So that's assuming that if I sat down and typed, and I've never typed before, I'd probably be able to type about 5 words per minute. Okay, so then it says, what's their average typing speed after 3 months? So now I'm going to substitute 3 into the problem. So I'm going to go back to this problem, and I'm going to change this 0 to a 3. So again, I used my LN button on my calculator to get that, and I get 45 words per minute. So now, after 3 months of practicing and typing, I'm going to end up with 45 words per minute. And then it says, use your graphing calculator to determine how long it will take you to get to about 65 words per minute. So Now we're going to go to our calculator, we're going to put the equations in, and we're going to put in 65. So for my window, I know my x-min is 0, and my x-max, according to what they've told me, has to be 16. So I'm not really sure what are normal typing speeds, so I put in the x-max would be 0, and y-max would be, I put 160. You know, I think that would probably be super good typist, but anyhow. So we're going to graph this. Whoops, we're going to graph it. And there's our typing speed. You'll notice that it increases over time. It eventually sort of tends to level off. And there's that 65 words per minute, which looks like it's about halfway where we're going to be. So if we find the intersection between those two, we find out that the intersection is 6.9, so that would be 6.9 months. So if I did this and I rounded it to the nearest tenth, it would tell me that it's going to take me 6.9 months, so almost 7 months before I could get to 65 words per minute. And then if we look at this table and we look at the values that we have here, so let's see. Sorry, look at our table settings, and let's go up to like 16 for the table start. So you'll notice at 16 I'm at like 87 and 88 and 89, and it looks like at about 111, 112, 118, it looks like about 126, 127 words per minute is where you sort of max out. It keeps going. But that's after like 92 months of practicing. Eventually, because it is a logarithmic problem, it will eventually top out. And so I'm not sure where we're going to top out at. So it looks like it keeps going up a little bit more every time. So I guess the longer you type, the faster you'll get. Eventually, it's going to top out at a certain place. Okay? So I hope this helps.